Hi, welcome to my video on the graph of y prime from the graph of y. And in this case, we're going to say y is going to be a cubic polynomial. So y prime is derivative. Graph y prime for each y equals ax cubed plus bx squared plus cx plus d. Notice that y is a cubic, so its derivative is 3ax squared plus 2bx plus c, and the derivative of d is 0. So when you take the derivative of a cubic, you get a quadratic. So how do we don't have any points on the graph, so how do we graph the derivative? Well, the derivative is just only just a sketch to show you what's happening. So what happens, I'm going to use a red color for the derivative. So if this is the graph of y, so what you do, this is the maximum point, so you drop a perpendicular down to here, and you drop a perpendicular to here, because this is the minimum point, this is the maximum point. So what happens in relation to doing y prime, then whatever this coordinate is for x, this minimum point, this x value here is this one right here, and this is the maximum point, so this x value here goes to here. So how does the cubic graph, what is this, the slope of the cubic graph on this side? Well, that's a positive, so that means that it's a positive slope, so it's going up like that. And over here, this is point, so what's the slope of this one? This one is a positive also, so that's going up like that. Remember, the red is y prime, the derivative. And in between here, in between these two, this slope is negative and a negative. So it comes down, and whatever this midpoint of these two are, so whatever these values are here, the middle of it will be the vertex, like coming down, and then it bends and goes up. So because this is a cubic graph, then its derivative is a quadratic, and see the quadratic parabola shape. And we have another one to do. Let's just keep showing. This is a maximum point, so we come down to here. This is a minimum point, so we could go perpendicular to the x-axis. So this x value here is this one. This x value here is this one. So that's red. And on this side, the slope of this cubic is negative here, so that means it's there. And the slope here on this cubic from on this side, left side, that's a negative, so it's doing that also. Remember now, this is y prime. This is the slope of this curve, slope of the tangents to this curve. And halfway between these two values is right, whatever these two values are, the middle is here, so this is, notice this is, as you go up here, this is positive, and then it changes. This is positive, from here to here on the slope. So it goes up, hits the middle, and then it comes down. There it is. Again, this is y prime. Let's do another one again. So this time we have its tangent here and passing through here. So this is because it's cuts the x-axis and x-intercept, then this is the minimum point and this is the maximum point. So we take this point and we drop it down to here. So now I'm going to do y prime. So we got this value of x here is right here on the x-axis. This value is already on the x-axis. So on this side, that's a positive, so it's going up like that. And on this side, that's a positive slope, So that's doing that. And halfway in between, whatever these values are, right in between is halfway is here. So this will come down and then right at that middle. That'll be the vertex of this parabola. Again, this is the vertex of this parabola. This is the vertex of this parabola. And again, this vertex is halfway between these two values of x. And this vertex is halfway between these values of x. And this vertex here is halfway between these values of x. So this is y prime, the derivative of this cubic. And the derivative of this cubic is a quadratic. Okay, another one. Same again, right here. We got a peak point, but that's a maximum. And this is the minimum. So we perpendicular to the x-axis. So we pick up those values here and here. And on this side, this is the slope of this curve here is negative, so we'll come down like that. And on this side, this slope is also negative, so we'll come down. And halfway in between is right here, so we'll take these and go up. So let's say it goes to there. Just an estimate. So there it is. Again, this is y prime. Y prime is the derivative of this cubic. The derivative of a cubic is a quadratic. Okay. Now, what about if we have a cubic? Notice this cubic has only one bend right here. So, what is on this side? This is only one point. So, here it is right here. Now, this side is positive slope, so it's doing this. I can do it. And on this side, there's a positive slope also. So it's doing this. So notice the slope to the left of 0, slope to the right of 0, and the slope to the left of 0 of this cubic is always positive. So that means the parabola is going up from 0, positive. So this is the y prime. Again, the derivative of a cubic is a quadratic. And this quadratic just looks different. Now I have a summary of y prime, the derivatives. So if we have, just going to do a couple, show you now, what about if we have a constant? A constant is y equals c. So what about if we have a constant that's like this? This one could be y equals 2, y equals 1. So the derivative, the slope of this is 0. So it's y prime is right there. Or what about if we have a constant that's a negative, like this? This is y equals negative 2. The derivative of a constant slope is 0. So the slope is 0. There it is. That's y equals, so that's y prime. 0. And what about if we have a linear? What about y prime for a linear? And let's draw a grid. Let's draw a grid for a linear. So we got a linear. We could have a linear that's positive. And a linear could be y equals ax. And this is a positive, and this is a negative. So the slope of a linear is, the derivative is y equals a. Because this is a positive slope, so if the slope of this is 2, then this is y equals 2. And if this is a negative slope, then its derivative, let's say the slope of this is negative 3, so y equals negative 3x, its derivative is right here, y equals negative 3. So this is y prime and y prime. This is a positive slope, so it's y. So the derivative of a linear is a constant term, horizontal. Derivative of this linear is a horizontal. Slope is negative, slope is positive. And let's do the quadratic. What about we do a graph of a quadratic, and we do a couple. We got one quadratic doing this, and we just take the quadratic and turn it upside down and see what his graph is going to be. And if we have a quadratic, the derivative of a quadratic is a linear. So this x value here, it goes to here. There it is right there. It goes on. This x value. The vertex, the x value, the vertex is here. So on this side, this is a positive. And on the left side is a negative. So remember, this is y prime, the derivative. This is a quadratic. The derivative is a linear. And this is, oh, what did I do here? I had two of them, sorry about that. I had two of them going the same way. I didn't want to do that. I want to put one up and one down. Because this one goes down, this is a maximum point. So we go on perpendicular to here. So whatever the x value is here, it'll be right here. On this side is a negative. And on this side is a positive. But the slope is negative, whatever the slope is. But on this side is the negative in relation to this x value. And this side slope is positive in relation to this. So this is a y prime. And we do one more, just making sure, cubic. Let's see if I can draw them correctly this time. I have one going up and one going down. That's what I'm trying to. So this is the positive one. So this quadratic right here, I didn't put the equation, could be y equals ax squared. Or it could be more than that, but I just want to, the vertex is off, so the equation has a x squared and x and a constant here. And the cubic is y equals ax cubed. Again, this cubic should be passed through 0 here, but I didn't do it. And let's have it coming up from the bottom and doing this. So let's see this point here, go down perpendicular right here. At this point here, we go perpendicular, take this point. So on this side, this slope is positive, so it's above. And this point right here, this slope is positive, so it's above. And the midpoint, let's say it could be here. So we just curve. There it is. Y prime. Derivative of a cubic is a quadratic, parabola. Derivative of a cubic is the cubic. So bring this value of x down to here. Bring this value of x to here. And on this side of the x value, that's a negative, so it's down here. On this side of the x value, that's a negative, so it's down here. And the midpoint of these two right here, let's go up and do this. And this is the y prime. Again, this is a cubic. So the derivative is a quadratic. Just wanted to go through that to show you. Remember, in the previous videos, I did the quadratic one. Now I just wanted to summarize them all and put the cubic in here also. And again, if you like my video, click the like button, click the subscribe button. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. The content on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Hope the video helped you. Bye-bye.